I believe I had lost some recording earlier. I thought I had pushed the button for recording, but apparently I hadn't. So I think the last session wasn't all recorded. So Vanessa, I see that you're here. I'm very sorry about that. I was hoping that you would have been able to get the full session. I'm not quite sure when you joined us, but I hope that you joined us early enough in the discussion not to have lost some of what we had been saying about the lesson. All right? So let's see how that works. Oh, that's great. That's great, Vanessa. It means that you were able to get much of what we were saying. I had lost the feed. Okay, good. Now, so we're gonna just detour a little bit, perhaps for about another 15 or so minutes, and see if we can just address some of the problems that are related to this particular lesson, and then see how we can now make that link into the real physical lesson plan. So Samuel, you're on. He laughs.
Yes. The concept of the activity will be rate of reaction, or what we call rate of chemical reaction. And for those who are not really familiar with that, well, rate is about how slow or how fast a reaction will take place. And when we say reaction, we're talking about a chemical change. So that means in that activity, the student want to take note of the chemical change that will take place. So we call it rate of chemical reaction. And in that activity, the reactant will be magnesium and oxygen. So they're looking for the product. Now, when we talk about chemical reaction, there are some factors that normally affect the rates of which the chemical changes will take place. The common factors are pressure, temperature, catalyst. So in this activity, the teacher wants the student to use temperature to see how temperature we affect the rate at which magnesium will react with oxygen. And also, we can always measure the amount of reaction that take place. To measure rate of chemical reaction, we can check the volume of gas coming out. We can check the amount of particles. We can check the color. So in this chemical reaction, the student will be checking what happened to the mass of magnesium, because the mass of magnesium will tell how much reaction take place. And also, I think it's about a few minutes to be given. So at that few minutes, the teacher wants to know how much of reaction take place using what? Temperature as a factor. So in that, like I said, the reactant will be magnesium and oxygen. The product will be magnesium oxide. So to summarize everything, the factor that will determine how fast or how slow the reaction takes place is temperature. And to measure the rate of reaction, we check what happened to the mass of the magnesium before heat was applied, and what happened to the mass of magnesium after heat has been applied. So we check the difference in the mass of magnesium. So that's just what the activity will be, rate of a chemical reaction. And please, you know that when we talk about a chemical reaction, that means the product cannot be reversed but with a chemical technique or method. So that's just a summary of what the activity will be on.
All right. Anybody has any comments on the focus of the activity based on what comments or questions Samuel has just said?
I have to say, I don't think that was the point of that experiment. I always thought that experiment was to show a type of bonding.
Okay.
No, Tracy, you see, she said they measure the mass of the magnesium before they put it on the crucible. So that means they want to know the initial mass of the reactant. And after, she said, she give them like a few minutes, they will now remove it to now see what will now be the new mass of the reactant. So just to show the amount of reaction that take place. So it's about rate of chemical reaction. Thank you.
Do you not agree that the new mass is going to be heavier than the original mass because magnesium oxide weighs more than the magnesium?
You're right. And like you see, and also to depend on the amount of heat applied to it, because the factor that they want to use in that activity is the temperature, to see how much of heat is applied and how fast the chemical reaction is taking place between magnesium and oxygen.
But they don't take the temperature, and they don't say how long it takes to burn the magnesium. I was always under the impression that you have a roaring flame because you need to burn all of the magnesium and get the oxygen in to get the end product, which is magnesium oxide, which if the experiment is done correctly, and I'm a biologist, so I don't like when I don't understand something. And to me, this is all about bonding, and it's ionic bonding. I don't understand why. I know it's a metal and a non-metal, and can't go any further than that. But I just don't see where this is rates of reaction.
Like I said, because the mass of the magnesium needs to be measured before the reaction. That is one way of measuring what the product of a reaction. You check the mass of the reactant before and later. She said after a few minutes, they will remove the magnesium to not check the new mass, so they can know how much reaction has taken place.
Jason, you were gonna say something?
Yeah, I just had a question. So what are they using? Okay, they're measuring the weight of the magnesium before and after, but what are they using to measure time?
She said a few minutes will be given. For example, if you find she'll give them like, it can be 20 seconds or 30 seconds to see how much reaction has taken place with the temperature they use. So for example, with heat have effects with the amount of heat, because you'll be surprised that depending on the heat from the Bunsen burner, they may have different mass at the end of the experiment, because the amount of temperature will determine how fast the magnesium will be reacting with oxygen.
Well, did the teacher instruct them to measure time?
No, she will give them the fixed amount of time. She can say, okay, fine. Start now, in 20 seconds, I will stop you.
But I mean, did she do that? Did she do that? That's my question.
No, she said they will use a short amount of time. And after then, the remaining magnesium or the product from the reaction will be taken out and measured again.
Are you done, Jason? Sorry.
Basically, I mean, I don't see where she mentioned time or said anything to them about measuring time or anything like that. It's the only thing she said about time was she was giving them 2 minutes to make the prediction and to get their apparatus. But other than that, she didn't say anything about time.
Is okay. You see, like the initial time I watched that, I was not conscious of it, but she made mention of it at the initial state, that measure the mass of the magnesium, and later you remove after a brief period of time, which will be fixed for everybody. So she will determine the amount of time that will be given to them. Like, wow, I say, okay, that is a topic. That's a concept, rate of chemical reaction.
I just had another thought. Can I ask? Is it to figure out the chemical formula of magnesium oxide?
All right, maybe it's about time that I jump in, because it's, I guess I should. All right. Samuel, the lesson was not about rates of reaction. It really was about bonding, and it was about finding the chemical formula for magnesium oxide. The cues that you were supposed to be using now, I don't know if you've ever done this activity, but remember that the Magnesium burns in oxygen to produce magnesium oxide. The reason for the crucible was to control the magnesium oxide. You know, it sublimes, and so when you heat it, you see that white fumes that you get when you heat magnesium in the lab without containing it. In the crucible now, the expectation is that none of that would be lost to the atmosphere. Hence, you weigh the crucible before, you put your magnesium in, you weigh it with it, you heat to completion, you heat it, you weigh it again. You would, as Tracy had said, found that the mass at the end, having cooled and checked the mass at the end would be greater than what you started with. Mass of the products now. That is the whole basis now for us to discuss. What has happened to the magnesium? It has combined with the oxygen. How much? We can do a subtraction. We can determine how much was the mass of the magnesium, what's the mass of the magnesium oxide, how much oxygen has been added. Yes? And we can actually do some calculations if we want to move on from there to determine how many moles of magnesium, how many moles of oxygen, and perhaps the empirical formula. That's where the teacher is going with that list. That's the slant taken. So that approach is really about bonding. It's not really about rates. It's about chemical reactions, yes, but it's about how it is that they combine chemically for magnesium oxide. Yes, Samuel.
So, okay, why do you think she asked them to measure the mass before, and after a brief period of time, they'll measure the mass again?
Because after a period of time, the magnesium is going to burn to produce magnesium oxide. And it's burning in the crucible, covered crucible, so as not to allow any of the magnesium oxide to escape into the atmosphere. So you retain all of it in the crucible. And so you can then determine exactly how much magnesium oxide was formed. There would be, of course, some loss to the atmosphere regardless of how much you cover the crucible, but that's experimental error. That's the reason for it. Have you never done this experiment before? How do you normally teach bonding then? What do you normally do?
I've done this experiment a number of times in my class. Bonding is more like theoretical. That activity, there's no way bonding can be verified in that.
Please pause right there, Samuel. Pause right there. Did you hear what you just said? You said bonding is theoretical. There is no way that activity can lead to bonding. I beg to disagree, because there's nothing in chemistry that is theoretical. Chemistry is about reactions, it's about change. The challenge we have is to bring the correct reaction to bear on the theory so that we can share with the students and they can have an understanding of what is taking place. So what really was taking place is that the teacher wants them to see that magnesium will combine with oxygen to produce something else. It's called magnesium oxide. Hence her questions. That's why the questions were slanted in that way. And I guarantee you that if you check your textbooks, you will find that in some of the texts, instead of using magnesium and oxygen, they may use iron and sulfur, though that one is a little bit difficult to manage because the iron sulfide doesn't form as readily as magnesium oxide. But that is the purpose of that activity. The purpose of the activity is to introduce bonding, not rates of reaction. I know you're not convinced, you know. Are you convinced?
No, because it's a lab I've done about rates of reaction.
All right, here's the question. Here's my point. The fact that you use the same chemicals, all right, to carry out the same reaction doesn't mean that the purpose for the activity is the same. I want you to hear me. It's important that you hear me. That there are many things that you can get from doing one reaction. You shouldn't be bogged down if you say you do this plus that. The only thing you can do is end up somewhere else. You can react magnesium with oxygen, and it's about bonding. You can react magnesium with oxygen, and it's about rates of reaction. You can react magnesium with oxygen, it's about chemical change. You can react magnesium with oxygen, and it's about acids, bases, and salts. It doesn't have to be about the same thing. And so my point is that for purpose, you have to, teaching is about purpose. And you must recognize that there are many, don't lock yourself in. I don't want you to lock yourself in. I want you to become a bit more divergent in how you think and how you reason about how things work. You've got to be more divergent, because there are many, many, many ways to do the same thing, to do one thing. There are many ways, and if you lock yourself into an approach, you are robbing yourself of a myriad of possibilities. I don't want you to do that to yourself. All right? Are you any more convinced now, Samuel? He laughs.
Thank you. But like what I'm also thinking is, if I'm asked to grade what concept that activity will be, like I said,
yes.
Okay, rate of reaction followed by a chemical reaction before I can go to bonding.
Yeah, but
so
Go ahead.
How before I can fine, because in the questions, that's I was like, wow, why is she asking bonding? That's, to me, before I can even go to bonding, I'll go to chemical reaction.
But we don't know where she's starting. You're assuming that the students know nothing. That's what you're assuming. All we have to go with is the fact that within this class, the teacher has done this activity. She has set it up to address these outcomes. And the issue really then is this activity useful in this context? Bearing in mind that she would have considered previous knowledge, she would have known where the students are coming from. They have done that before, they have done what they have done before, and how can you build on what they have learned to move forward? All right? So I want you to, I really am spending some time in this for the rest of all our benefit, but I really want you to begin to free yourself of the tendency to be locked into a one way of thinking, and allow yourself to think differently, more broadly about possibilities, so that creativity, that creative spirit that I'm sure is somewhere inside of you can come out as a classroom teacher, so that you can really begin to do different things with the same thing. Okay, so the familiar becomes strange and you use it differently. Okay, so you don't just do the same thing this way every day, one way. You're going to be boring. It's not going to be fun. It's going to be a chore.
And Doctor, my last statement, I agree to everything you said.
Yes.
But the only part there is that I'm asking myself now is,
yes,
what does measurement of magnesium have to do with bonding?
All right, let me go again. Let me see if I can explain the concepts slowly. All right. The mass of magnesium.
Excuse me.
Yes, Ashley.
Can you just say that there must have been a change given that the mass is different?
Yes.
Change has occurred given that mass is different from when you started.
Correct.
So Does that answer your question?
Yeah, Ashley, and what you just said is just how you can measure rate of reaction.
But my friend,
Yes.
was there any time? Was there any time? Did the lecturer say, students, have your stopwatch ready, and you are going to find the time in the experiment to be 20 seconds under roaring flame?
And then temperature, the heat, the flame would have to be modified at some time, no?
Exactly.
Little that I know of chemistry, I mean, that's not my baby, but I got it, Samuel, from just the questioning and what she did. And she actually said about the bonding, she said, is a metal and a non-metal. And she said that, and the first question that was prominent was, will magnesium be, what type of bond it is? That was the first line of questioning. But I don't think Samuel is very convinced that we
he's
can
not.
do other things with the other lesson. But I guess later, I don't think it's, because I got it. That's not my baby. Chemistry not my baby at all. So, but I got that, that was born, and she said it, and we're going to look at that, and they have the questions that followed and stuff.
Yeah.
And as I said, probably we should be a bit open-minded. But it's a lesson. I'm getting a lesson now. I'm reflecting on myself and stuff, Samuel. So we get so comfortable doing the same thing and getting that we tend not to see other ways. But I'm happy that Dr. Rainford, that you're doing it, because I have a lot of light bulb going off in my head as a teacher. So
Yeah.
I'm happy. And Samuel actually can be one of my students as a resistant to change in knowing and stuff. So I'm seeing it from as a teacher and as a student.
Mm.
And I hope he's not offended, because we see that it happen in the classroom.
Mm.
Because at this level, if you're not getting it, and if you're not fully aware of certain concept and we bring it up to the students, they are the one that we're going to disservice, and then we need to really open up our minds and then be able to better deliver. You know, from a self-assessment to see that, you know, I can do better than that. I can, you know, really get it. And I'm thinking about myself and hope that others don't feel, you know, but it's a teachable moment, and I really like the discussion and where it's going, and a lot of reflection for me personally.
Yeah, thank you, Eva.
All right.
I've just sent Samuel the experiment so that he can see where it's going.
Yes.
A link of it. It's not the one we use at our school, but it's one I found online.
All right, fine. Excellent. All right. Thanks for that, Tracy. Thanks for that, guys. It really helps when, you know, we can pull together in this way. This for me is my moment. This is my moment. I'm really happy it's happening now, but yeah, this is my moment. I think I must journal this moment today. When I go home, I must write about this, because it's also for me the moment when we, perhaps it's because we're not in the same space, I don't know, but we are forced to think and listen and problem solve in this way across the Caribbean. and yet we can still come to that place where we understand, and we can see and think and feel and appreciate what's happening. So Samuel, I'm happy for this, and I'm really happy that I stopped to follow my instinct to go further, because sometimes you have to do this. Sometimes you really have to stop, and you've got to think now on your feet and determine what's the best way forward. All right, I couldn't have done this better if I had planned it. All right, so that's great for me, and so forth. And when I see you next week, we'll talk some more about this. All right, I promise you, I'll sit with you and spend some time with you and talk some more about exactly how you could do it and what are some of the limitations of this approach. But it's an exciting way to introduce bonding. Can I tell you? It is an exciting way. All right, so let's look back now at the other questions, the other issues.
One second before you move on. When are we seeing you next week?
No. I'm seeing Samuel next week, but I'm seeing you the week after too.
I missed.
No. I'm seeing we're doing the St. Lucia, Dominica trek next week, and then we see you the first week in September. That's when we see you. All right. So don't panic yet. Hold on to the panic. All right. So then, but the other questions then become, how is it? If the questions now, do the questions now relate to the, the exercise? Do you see? Linton, let me see what you say. Hello, Linton.
Yes, I'm there.
I know you're there. I can see you. Yes.
What is the question?
Oh, goodness. I'm asking you what the second set of questions I asked. Remember, I asked the questions about Samuel should start by telling me about the activity, and then you are now going to focus on the rest of it. If the questions that the teacher had asked posed on the board, if they do in fact relate to the activity, and if they don't relate to the activity, what other steps can the teacher take to ensure that she gets them to that point?
Okay, yeah. Okay, well, according to the discussion we just had a while ago,
Yes.
I was looking at it, well, with chemistry, like bounding, I was seeing it like something that is, let me see, I can't find words, eh?
Yes.
Okay. I was seeing bonding as something that students who has a background in chemistry already. For example, at our school, the way we do chemistry is that we use the form freeze to actually do the basic ionic bondings and covalent bondings with those students first. And then when they select the subject, then we go into depth.
All right, Linton, you're not answering my question. I asked you a specific question. Pull up the messages that I, that I sent and look at the question I'm asking you to answer. All right, I'm coming back to you. Okay? I'm coming back to you. Vanessa, I haven't heard you from morning, my darling. I'd love to hear your voice. Can you share with us now? What do you have to say? Vanessa. Oh, Vanessa. Are you there, Vanessa? Vanessa, are you there? See what this thing says. Okay. Okay, Ashley, go. Any thoughts on this, Ashley? Ashley, are you there? Hello, Ashley. All right, everybody has gone.
Sorry, 1 minute. I'll be right back. Sorry.
All right, okay. Okay, Jason, let's hear from you.
Yeah, for me, like when one of the questions was, will oxygen, or will it be ionically or covalently bonded, magnesium and oxygen?
Mm-hmm.
And I think that bonding is an extremely abstract concept
Mm-hmm.
that you can't really see the electrons and everything that are being associated with the bonds by conducting this practical experiment.
Mm-hmm.
So I didn't feel like the practical is effective for that, but I thought she could maybe have incorporated like some models.
Mm-hmm.
So I know in the past in my high school they had these like plastic models that, one like a black ball would represent oxygen and it had the right amount of holes that represented the how many bonds it could form and stuff. And like, so having students actually construct like a molecule of magnesium oxide using a model, I feel like would be helpful, more helpful than just conducting the experiment. It should be done in conjunction with the experiment, I think.
Okay. All right. Tracy, you would have met some of this before because you have worked with students doing this.
Yeah, I think where Jason's falling down is at his chemistry. Jason, what the bottom line of this experiment is, I couldn't remember. I've done it. I mean, I've gotten it ready as a lab tech many times, and I couldn't exactly remember how it all went down. But I've looked online. The purpose of this experiment is to come up with the empirical formula of magnesium oxide, which they're able to do because of the weight change, and then they do a ratio. If you look, I'm just getting Linton's email address. I'm going to send everyone the link that I found. It's a very simple experiment, but it is a very effective experiment, and I think if I send the experiment to you, it'll be very self-explanatory. It's people are getting off track, I think.
Yes.
Really? What about like the questions that she asked those students who didn't understand? They didn't understand because they couldn't see it in my mind. They didn't understand how the magnesium would bond with the oxygen.
Even though I disagreed with that at the beginning, now that I know where this experiment is going, because I mean, you know that I'm biology. The only reason I know this is because I know that the children always have a problem with getting the weight difference. So I knew I had to figure out why this experiment was done. So I looked it up, and if you get to the bottom of this experiment, it does make sense. It's all about the ratios and.
Yes, it does.
I'm gonna send you the link, and you can see if you disagree. The kids do like this experiment, and it does lead to a lot of discussion because there's a lot of wrong weights. I do know that.
Right.
Samuel, Dominica?
Yes, Samuel.
Tracy, are you saying it's about empirical formula? You said that. Did I hear you saying that?
It is a way to work out the empirical formula, yes.
Okay, do you know why I asked? Because empirical formula is another concept. So I want to try to link both together. Because you see, if you say empirical formula, then I can say, wow, they need to get the mass before and after. So I'm not like, wow. So because it's, okay, based on the bonding is a concept, empirical formula is a concept. For sure, you need bonding to do empirical formula.
Yes.
So if you're saying it's empirical formula, then that's another concept. But you need to know about bonding before you can deal with empirical formula. So Tracy, am I hearing you saying it's about empirical formula?
The question said that, the question the teacher asked, the last question, what do you think the empirical formula of magnesium oxide will be? She did ask that question. That's the last question on the board.
Wow. Okay. I didn't see that.
Can I take a side on this too?
Yeah.
The reason the reason I didn't get what this experiment was about was because I thought she was a very patronizing teacher. And remember I said how it was boring, she was telling him to do this, this, and this, that
Yeah.
I actually did not listen to her questions. So I think that's a good point to bring up, because I thought she was so patronizing with the tongs and the this and that.
Yeah.
I didn't listen to her questions.
Yes. But when you listen to her questions, you found out that
I knew exactly where it was getting.
Exactly. Now, this is perhaps this is a good exercise because it really allows us to do so much with it. And perhaps if our knowledge of chemistry, if all of us had, a stronger base, then it would perhaps even be more, it would be able to go so much further with it. There's one thing that she did though, which I want to point out, and we may not be able to address.
Sorry.
It. Yes, Ashley.
Just wanted to add, because they took the measurements of the mass.
Yes.
That might be able to identify the bonding questions that you had us analyze.
Yes.
As the masses are different, we should be able to, she can ask questions like, what's the difference of the mass, the masses, and then how much magnesium did we have? Then using the mass of a magnesium, they can find out how much magnesium versus oxygen is in the resulted mass. You know what I mean?
Correct, yes.
So that can help the students understand that there were bonds occurring in the experiment.
Yes.
Does that address your question?
That's correct.
Did somebody say that already?
Well,
but how would that? I thought that would be the case. Like, how can they identify whether it's ionic bonding or covalent bonding based on the mass.
All right, they can't identify. They can't identify that.
That was one of the questions that she asked.
That's the knowledge. They can only deduce that it should be ionic. She said, remember, metal and non-metal combine to give you ionic bonds. So they can only deduce that it should be an ionic compound.
Well, yes, by the definition given to them of what an ionic compound is, and then by working out the mass of the end result, there are only so many chemicals that are around the same mass as oxygen, right?
Mm-hmm.
So can't we deduce that the oxygenated or magnesium oxide, like what else could have happened in the little pot to give a mass that was around this mass?
Nothing else could have happened in the little pot, which is called a crucible, to show the reaction.
I didn't realize that she said what an ionic bond was. I didn't remember that.
Yeah, that's what it was. And but I want to say one thing though about that bonding thing. There was a slight error in her conceptualization of an ionic bond. She speaks about how many bonds. She asked that question several times. How many bonds will oxygen combine with how many bonds will they combine with oxygen, magnesium and oxygen, and similarly with oxygen combining to magnesium? That technically is an incorrect question, because ionic bonds are different from covalent bonds, and there is no this is the ionic bond. There is none of that. It's for a covalent bond, you can say this is the covalent bond. But with ionic bonding, it's an attraction that is multidirectional. And so you cannot have this is the bond. So the question she asked is an incorrect question. I understood where she was going with it, but there was a slight error in her conceptualization. She used the wrong words. She couldn't ask, she ought not to have asked how many bonds, because you cannot say how many bonds. You can say how many bonds if you're dealing with a covalent compound, but that question, how many bonds, cannot be asked of ionic compounds. So that in itself was an error in the argument, in the discussion right there. All right. But outside of that, I think she was crystal clear. I could see where she was going though. She was talking about the fact that electrons combine to form bonds, but it's quite different for ionic compounds than for covalent compounds. All right. So in a nutshell then, this is our little discussion about teaching and learning. You can see we can go many places with it. We have some other stuff to do which I want to do, and I don't want to take this much further. But I really want us to appreciate the fact that, you know, if we look back at her lesson and how she also presented it, the students themselves seemed perhaps a little bit intimidated by what was being asked, but she tried to get them to think it through before. She sort of had an inquiry approach to the whole activity. So tell me what you think will happen. Tell me what you think is going to be the outcome. What do you expect? So before they start the activity, she's sort of helping them to think in an inquiry mode, and then the activity, and then I guess the discussion. All right? But anon, enough of that. All right, we're going to have to stop that there, and I want to thank you for your input and for your patience and for the fact that you all shared so willingly. All right, now for the last hour and a half or so, I want us to look at some lesson plans, and there are 3 lesson plans that are on the site. The 3 of them are related to the series of ideas, and this time it's on genetics. So I think everybody, more persons know, I think most persons should be able to appreciate the concepts that are involved. All right? So I want us to take the 3 plans and I want us to look at the 3. They're titled lesson 1, lesson 2, and lesson 3. All right? I want us to do a number of things with this activity. So firstly, I want us to look, and you can talk to each other chat-wise. Here's where we can do a little conversation, so you can talk about it among yourselves. I want us to first look at the objectives, and I want us to determine if these objectives are properly written. That's just the first part. We're not talking now about whether or not you should have cognitive, psychomotor, and affective. I just want to look at the structure of the objectives. Are they properly written? All right? The next thing I want you to do is to look broadly now. Look across all 3 lessons and see if you can see continuity. If you can see where lesson 1 would lead naturally to lesson 2 and lesson 2 to lesson 3. Okay, that's the second thing I want you to look at for me. And then I want you to look at the resources that are used in the lesson. Look at the resources, critique them. See if this is really a good resource and why. Pick any one. And I want each person to come back to tell me about one resource from all 3 lessons, from any of the 3 lessons. Sorry, not from all 3, from any of the 3. So you're going to focus on one resource. You're going to pick it apart. Tell me what you think about it. For you to look at the resource, you need to be able to look at it in terms of how it relates to the objectives, yes, and look at the quality of the resource. Look to see if this is something that you'd want to spend some time looking at. All right, so let's look at those 3 things for now. Objectives first, okay? The continuity across. Can you see a logical pathway from lesson 1 to lesson 2, lesson 3? And then you're going to look at the resources, but you're going to pick one resource. Pick one resource. Look at that resource in light of the objectives and where it is placed within the lesson and see if it makes sense. Pick it apart. Look at its strengths, look at its weaknesses. We're going to talk about that one resource, and you will each address one resource. All right? So now let's take another 10 minutes. Hopefully we don't need more than that. 15 minutes max. And see if we can do that. And I'm encouraging you to have a cross conversation. So pick a partner or pick a threesome, because there are 7 of you, and have a conversation across the web. So I want you to talk to each other on this one, and then you can then share. We'll share. All right.
I appreciated the written instructions last time.
I'm going to do that. I'm going to do that now. All right. I'm going to put it up right now.
Thank you.
Mm-hmm.
Where exactly are these 3 lessons?
All right, if you go to, let's get this right now.
It's on the course page, actually, just the sample lesson plan.
Yes, that's it, sample lesson plans.
Yeah.
Thank you.
Ashley and Vanessa, cartridge paper, I think, is that it's like a thin black paper that you put between 2 pieces of paper, and it copies when you write on one side, it copies it through the other side.
No, cartridge paper is like poster paper.
Okay, thanks.
Hmm.
We can't hear you, Dr. Rainford. You've been talking to yourself again.
Can you hear me now?
Yes, we can.
I keep on turning off the speaker on this thing here, and I keep on forgetting to put it on. All right. Thank you, Eva. Yes, I'm saying that what we have pretty much here is a series of lessons done by the same person on genetic variation, and we want to look at the lessons at this point. Now, the lessons do not reflect the 5E model. They are, one could say, they are inquiry-based lessons, but they don't. They were not asked to write lesson plans based on the 5E model, but they had to. It was a group of students like yourselves who did this. When one person from that group did this, and they were asked to do a series of lessons to address a particular concept. That's what happened with that in that case. All right. So then let's talk about the objectives, and let's see if we can go around my screen. Vanessa, I'm starting with you now, since you have I haven't heard your voice at all since the morning. Let's see if we can hear you. Okay, I've got another message. Okay. I believe that we're seeing Vanessa's post. She thinks that the specific objectives are clear and measurable for all 3 lesson plans. Is there anyone who disagrees with this? Were you able to find any that were not properly stated?
Samuel?
Go, Samuel. Tell us
Yes.
the lesson. Tell us the lesson and the lesson plan.
Yes, I check lesson 1.
Lesson 1.
Yes, the second objective I see observe, record, and report.
Yes.
To me is, and following the Bloom taxonomy, the order, the writing specific objective should be from low order to high order. I noticed the start with distinguish, which is more like analytical question. From there, jump back to number 2, which is just like knowledge question.
Okay.
So I noticed from the objective does not go from low order to high order in thinking level. So I noticed about that, and like I said, objective number 2, the 3 verbs were used just for one objective alone.
Okay, so you are saying that because you would like to suggest another approach. What would that be?
Yes, I think the objective number 1 should be maybe observe some human variation. Then from there, that which is low order thinking, it can go to distinguish which is the first objective that the student has there. And he or she doesn't have to use 3 verbs to explain one objective.
Okay. Anybody wants to comment on that?
Oh, sorry. I would like to just state something. I don't want to comment on Samuel because I just think that's, oh, sorry, I can't say that. I can't say the word. For Mike, I had the objective, the same lesson. Lesson 1 was genetic variation.
Yes.
Just one observation. I'm not sure if it was down at the bottom, but she said, observe, report, and record on human variation. But she had a variation in plants and in the humans.
Okay.
I'm not sure.
The same lesson 1?
Yes.
Okay, so objective 2. You're referring to objective 2, and you're saying that it was observe and report on some human variations.
Yeah, but she also had plants
within the lesson.
Yes.
Okay.
But she did do the one with the airlobe. She testing the airlobe with the students and stuff. But I guess if you
Yes.
add in plants too, that would have covered both plants and animals, or humans, sorry.
Okay. I see the point you're making. I see the point
Yeah.
you're making. Yeah.
That's
Yeah.
everything I saw with that.
All right. I see the point you're making. All right. Thanks. Any other
But it's
comments?
yeah. But I think the lesson, but you didn't want to, and that, but the lesson was well planned and thorough, series of activity. I think you have a lot of things for engagement and stuff. So I
Yes.
did like the lesson. Not that I will do it every day because I spend a lot of time on that, but but it's, I mean, it's a way to go. You can use it as a model lesson.
Yes.
I like,
Yes.
yeah.
All right. Any other comments on the objectives?
In a lesson, maybe this is moving on to the next point, I don't know, but in lesson 2 and 3, some of the objectives are the same.
All right. Let's find lesson 2. Lessons 2. Tell me what they are. I have to find I have to tell me which ones. Read the objectives, I mean. Can you read the objectives, Jason?
Oh, sorry, I didn't have I have my mic muted. Yeah, explain
Okay.
the meaning of the terms allele, dominant, recessive, incomplete dominance, genotype, and phenotype.
Mm-hmm.
And also use genetic diagrams to explain how a single pair of hereditary traits are passed from parents to offspring. That's in lesson 2.
Yes, I'm looking at lesson 2.
In lesson 3, she also has explained the meaning of genetic terms, homozygous, heterozygous. So some are different, but then she has some of the same. Incomplete dominance, genotype, phenotype, dominant, recessive, allele.
Okay.
And
Okay.
part objective 2, use genetic diagrams to explain how a single pair of genes are passed on from parent to offspring.
Mm-hmm.
Those are repeated in each lesson 2 and lesson 3.
Lesson 2 and 3. Okay, so you perhaps the challenge that looking at it's a lot to sort of internalize in this short space of time.
Yeah.
But in looking across the set of activities for both lessons, do you see any sort of difference in why it is that she may have repeated those objectives there in lesson 3? All right, yeah, that may be something to look at. I certainly didn't do it, but I mean, it might well be to look at it. But thinking about it just off the top of my head, it may not be such a bad thing to repeat some objectives in successive lessons, because you might want to reinforce it and repeat it for emphasis, just to make sure that you in fact treat it again, so that students can get it.
Okay. Yeah.
But I take your point. I would want to spend some more time looking at it again more critically to determine if in fact the way in which the objectives were treated by way of examples and otherwise, if in fact if there was any greater depth or any variation in the use of specific examples, for example.
Okay, yeah.
Yeah. All right. But generally speaking, I guess I think we will all agree that the objectives are fairly well written. They are not too many for the lessons, and that's the other thing I wanted to draw your attention to. Samuel, I take your point that you had raised in the first lesson, but I don't know that it is such a difficult. It is such a. In other words, nothing is wrong with writing, observe, record, and report on some human variations. Okay? My concern with that objective is the word some. Okay? Because some really is not such a useful word to quantify or to categorize. We might want to spend some more time looking at this to determine what some human variations could be. Maybe to categorize them more specifically. Your point about sequencing the objectives, so we move from the more simple objective to the more challenging one. I am not so sure that the sequence here is out. I would want to look to see how it's sequenced in the lesson itself, and to see if the sequence of objectives matches the sequence of the treatment of the concepts in the lesson. That would be my preference. All right, because the truth is that you may not necessarily need to start at 2 to be able to get to before going to 1, if you think about it. Okay, and then it seems to me that the sequence of objectives here relates to the development of the concepts as it relates to the lesson topic. Right, so I wouldn't get too concerned about that. All right, so you have to think of your sequence of ideas as well when you're sequencing your objectives. All right, now
I also had another point, actually. Okay.
Yes, go ahead.
About the objectives, based on something that we read in Dr. Latibaudier's class.
Yes.
On writing objectives, it suggested that you should always include the condition first.
Yes, correct.
Like after the lesson or after the assignment.
Yes.
Or after the unit or something like that.
Yes.
And then also they recommended leaving out should be able to.
Yes.
Because that's like a given. So they said that students will, and then list. Students will explain why. Those were some other things I noticed.
And I'm gonna clarify why it should be will and not should be able to. What we're dealing with in particular is the whole business of learning outcomes. We have sort of moved away from specific objectives in some respects, and we have been using learning outcomes. And that use of the word will be able to, or students will, is supposed to be able to show what the outcomes are of the lesson. And that perhaps is why you're seeing that in this this more recent reference that you're using. I should say that these lesson plans have been written perhaps, let's get this right, maybe about 8 to 10 years ago. All right, perhaps about 8 years ago. And so you will find that some of the jargon may be slightly different in terms of how you use it. But I wanted to pull these because, well, the plans themselves are fairly in depth, as you can see from what the teacher has written. And I wanted to bring this to your attention, that the lesson plan should show what's going on in your mind. And this is one way of presenting it. This is great depth. Okay, and this great depth comes only after a lot of experience. And this person was a very experienced teacher. All right, but she did her training long after she had been teaching, and so she had sort of been steeped in her ways as well. Okay, all right. So those are the objectives. I don't have a big problem with them. I think that they are fairly well written, and like I said, there are not many objectives in any one lesson, but within the lesson, a lot is covered. Okay, and we could talk a bit about how the coverage of the concepts go in that sense. All right, let's go to the second issue, which is the issue of the continuity across the lessons. Continuity, issue of continuity. Tracy, let me hear from you.
I think so, but I'm a slow reader, so I only barely read the first lesson. and then I just been trying to breeze through it while you're talking. They
Yes,
seem to
yes.
flow, but I wouldn't want to be
Yes.
held to that state.
Yes, yes, that's all right. That's all right. I understand. I'm a slow reader myself. What about you, Ashley? Were you able to have a look at it?
Yes, I do believe that there was some kind of scaffolding or a progression in
Yes.
the complexity of 1 through 3.
Yes. Yes.
Learning different terminologies in the first one, progressing on to understanding how the mechanisms work of those specifics that they learned in the first one, and then understanding how it actually works in the last one.
Yes.
Shows a progression of understanding.
Yes. Thank you.
Thank you.
What about you, Linton?
Well, I didn't finish reading it, but in terms of the objectives, when I looked at it, it looked like it laid in path. Yeah.
The objectives made an impact. Is that what you said?
Yeah. No, it looked like it followed the freak
Okay.
lesson.
Okay.
Yes.
All right. Yes, it seems that way to me, but when you have some time, I want all of you to kind of look at them, look to see the continuity, look to see if there is any sort of repeating of ideas for emphasis and building on ideas, and look to see, how the concepts are developed. I want to spend a longer time on this last part because, well, I want to say two things about these lesson plans. It is clear to me when I looked at the plans again that a lot is covered in a given lesson, all right? And the time would be about 80 minutes for this particular lesson. And I first of all then wanted to get some understanding from you all, from your own perspective. And this would have, I think it's a grade 11 class. Is it grade 11? I think it's grade 11. I want to get from you whether or not, based on your experience or what you would have observed already, is this too much or is it enough for an 80-minute grade 11 lesson? Let me hear from the persons who are in the field, who have had experience of teaching at this level and looking at how much is in each lesson plan. Tell me what you
think it's too much. Too much.
Yes.
Maybe if there were 5 lessons, where 5 80-minute lessons, so that way you have time to recuperate, regroup, absorb the information and understand it, because if not, they're going to be feeling like how I'm feeling right now, which is like my brain is like having difficulty absorbing new information. I would prefer to give the students more time to be able to have a moment to think about the things that they're learning and concepts that they're learning. Have some time to give their minds the ability to figure out and connect the dots so that they can understand, or not understand, but be able to apply the information that they are learning.
Mm-hmm.
Better than ramming it all into 80 minutes per lesson. I think maybe, if they split it up somehow and give more time to, just a little bit more time,
Mm-hmm.
That's
I think that's a reasonable position to take. I do believe that it's quite a lot in the 3 lessons. I asked the question because this particular person who wrote these plans taught at a school of very high achievers. And for her, that was the norm. Okay? And so for many persons, this would not fly in terms of how much is being asked of students in 80 minutes. How much can the teacher get through in this time? But I want to also, I thought I should say that, because as I have said, this was from the background where the person's experience is, the students are very high achievers. They're very driven, and they could perhaps manage this easily in that time. But for the average normal group of students, Ava laughs. She says, my students are not even average or normal. They are. She's in stitches. The average student, it may be a bit much. Okay, so now I want to just put that out there. I think it is that you need to recognize that you have to know your students. You have to know how much they can manage. You have to know how much is enough. And that really comes with practice. It really is difficult to say this is the ballpark, because like I said, this was okay for her students. And it really was. I saw her students, and she could have got through this. Okay? But it might not work in every situation where you don't have sort of ideal situation. So I've put them as good plans, because they are good plans, but I want you to bear in mind that it may be, maybe Ashley, your number of about 5 might be a fair estimation. 4 to 5 lessons might be, you could perhaps get out of this. All right. Good.
A quick question before we move on.
Yes, go right ahead.
So I can't get any students for our lesson plan that we have to hand in. So I have imaginary students. So I was wondering, if I have imaginary students, can I pretend that they're really, really thick, and I don't have to put much in my lesson plan? This is a real question. Yes,
Tracy, that one is great. I don't think you should go that route. I'd rather want you to imagine that they are just ideal students. Or just average. Yes, yeah, just average students. And not, you don't have behavioral problems. Think of it, pitch it more to the ideal. All right. It's a good question. All right. So pretty much then, that's the context within which where this was written. This was also in the days long before the kind of access to the internet that you might have had in today's world. All right, so you wouldn't have had the sort of the wide breadth of activities and possibilities. So this, outside of the resources, came out of the teacher's head. All right, I want you to bear that in mind as well. And so what I'm really saying is that the opportunities are now endless. Okay, because she prided herself in being able to do this, to make her own thing. She was always very independent. So that's her. But now the possibilities are endless. All right, so let's look at the resources for a little bit, because we have to do a resource, and we want to get the resources right. So we're going to go around the room. Okay, I'm looking at you as a room because I'm seeing you're all in tiles on my desktop. So let us see if we can take them one by one. So let's go, Samuel. You're at the top of my screen. So here we go.
Wow.
Take a resource. Let's take us to it so we can know which one you're using, and then take us through it.
I think I will need help in that, but what I noticed in lesson 1, I saw, I was trying to relate the resources to the objective, and wow, I have some difficulty.
Which lesson, which resource are you looking at?
Yes, I saw bathroom skill. I was like, okay. So I think I will need help in that, because I couldn't relate the resource.
Tell me
the resources.
Tell me which one you're looking at specifically.
Lesson 1. Lesson 1.
Yes, but which resource?
I Let me go back to. Oh, is a teaching material. It's a teaching material. I was looking at lesson one, and I couldn't really figure out how the activity will go, so I didn't really do much with that. Okay, Tracy just helped me out with the scale that will be needed for the worksheet. So, sorry.
Yes. All right, so you're having a problem. You stopped at materials. Is that what you're saying?
Yes, because I couldn't figure out how the activity will go, and
Oh, but you only, but you didn't go down to look to see how the worksheet is incorporated in the lesson?
no, I was trying to figure out the level of question, whether it's low level or high level. So I was physically most basing everything on the objective, and I noticed from what you said, the content will have explained how to go. But I was trying to figure out from the objective.
Yes,
So
I
I
see
think
what you're
I
saying.
made some misjudgment there that the content will have helped me better than trying to figure it out from the objective, the weight rating and the steps.
All right. Okay. All right. Fine. I understand. You perhaps had not looked at it before, so you have to get a sense of the entire lesson, and you have to be sort of working to and fro, looking at the lesson objective, looking at the activities. All right, so we're on lesson one. Okay. Is there anyone who looked at a resource from lesson one?
I was primarily in second and third, sorry.
Yes, Ashley, go ahead.
I was primarily in second and third.
All right, fine. Anybody from lesson one?
I don't know if you'd get if you're teaching at an old girls' school.
Yes.
I don't think you can get them on those bathroom scales at that age. That I'm actually talking about from experience. We do not.
Tracy, I like your practical look at life. I really, really appreciate it. But you do have a point. They would not want to go on the scale. Nobody wants to know their weights. Yeah, that's a very good point. In an all-girls setting, and perhaps even in a co-educational setting, it may not work. If the boys and girls are going to be looking at each other's weights, right? So yeah, I do take your point. Continue though.
Oh, that was all my point.
Okay, all right. But look beyond that. Look at the resource itself, and see as it is laid out, and so forth and so on. What are your thoughts about it? Would it address your? Yeah, go ahead.
I liked it, but I don't know if I would have students doing all those graphs. Like I said, I couldn't read it fully, but it just seemed like draw histograms and then make your own scales for the other histograms.
Yes.
That almost seems like, I don't know, homework. Like I wouldn't waste lab time doing that, but
yeah.
Maybe we can't have the students in the labs all the time. So to me, if she's in a lab doing what she's doing, then that would be homework.
Oh, I see what you're saying. You use the time in the lab to do things that you can only do in the lab. That's it?
Yes.
Okay. All right. I think in this case, though, I'm not sure if it's actually in the lab, but outside of that, the idea is not to separate lab activity from the theory per se, but to integrate them. And I think this is what perhaps she had been trying to do in this particular lesson. Looking at the activity, looking at the structure of it, the layout of it, I just want to point you to some points about the activity. like I said, this was done several years ago. Perhaps now if you're going to do something like this and you're doing drawings, if at all you can do it in color, that might be useful for the students, if at all you can, because the fact is that it becomes clearer for the students as well as it is more attractive. Okay? Perhaps based on what you were saying earlier, the number of questions could be reduced. But in terms of the clarity, in terms of the layout of it, I think it is quite a good resource. And the other issue now would be, would you be able to get students to do that? Well, that's the point that you had raised, Tracy. Just to make a point about the lesson plan and what I expect, if you do have a worksheet like this in your as a resource, then I would want to see it done in a format that you would expect the students to use. Okay? So if they're going to write on the worksheet, then you should leave space for them to write on the worksheet. All right? If they're not, then that's okay. Instruction-wise, you need to make sure that the instructions are clear and that the materials that you are asking them to get would be readily available. If it is that they, you know, and they're linked back to your materials in your lesson plan. So there should be a relationship between what you say you're using and what you say you will need. Everybody's clear on that?
I think so.
All right, fine.
Oh, sorry. I liked her resource material.
Yes.
I think it was very practical, as you mentioned, that the use of the bottles and soil outside. And what I was thinking that it might not have been so difficult after on reflection for these students, because I'm seeing that they bring in multiple of discipline into the science.
Yes.
They bring in a math skill. They
Yes.
can use agriculture. They're using so many things that might be familiar with them. So I'm seeing that the lesson is not as difficult as I thought it was.
Yes.
Because the histogram and these things would have probably recognized from the math lesson, and as I said, the agriculture and the other science area, maybe integrated science and stuff.
Mm-hmm.
So they have, to me, a lot of prior knowledge to work through through the lesson with. So I can see the incorporation of that, and I think that's very, very good for the teacher to do that. The other point, I'm getting younger, so I missed it, but I get it eventually.
Yeah, the other thing I wanted to say about how she has written her lesson plan, which is just her style, is that with all the questions that she asks, she sort of gives you a sense of what she expects and why she has asked the question and the expected answer. So it becomes easy to see the sequence of the ideas and how the concepts are being developed in the lesson. And notice as well that she indicates the time for each activity. She indicates how long, or certainly an expectation of how long it should take, how much time is going to be spent on that activity. All right? Now, Ashley, I know that you're tired and that you have to internalize much more, but let me hear from you next. Your resource.
I was just looking at the references that she had, and according to Dr. LaPlatte, we shouldn't use references that are any older than 10 years old, and she's got one from like 1985 in both of those.
Yes.
So I was just
yes.
That was my
your concern. Okay.
Yeah.
Yeah. Well, I did say that this lesson plan was written several years ago.
Even several years ago. 1985 is like
no, hang on. Yeah, it was about 10 years ago. Okay, but your
That
point,
would mean that that source at that time would be 15, 17 years old.
yeah, no, I'm not finished really. Let me just finish. But it depends on the source. What source is it, is what I'm asking. Which one is it?
Whichever one states 1985 at the end of it. I
No,
can't
no,
remember.
sorry. What is it about? Some sources. My point is that you can use an old source. It depends on what the source is. If it is something which is historical, then you really have very little choice. If it is something that speaks to maybe it's I don't know what it is. I haven't gone back to look at it, but that's why I asked you what it was.
The nature of life.
The nature of
Life.
yes, and do you remember how it was used in the lesson? Because it might well be that there's a story there, a historical document that was used. You see what I'm saying? So it's
Right.
you can't make blanket statements.
Okay.
Generally speaking, you can say that if there are current issues that are being dealt with, then you should really use current sources. But there are some documents that look at, say, the history of science, where you're looking at the stories of science, that you really need to go back to the historical document. And
Thanks
that might
for
well
clearing
be
that.
that might be the case. I'm not saying it is. I'm just saying that you have to
I
always
understand.
look at it. Yeah. All right.
Thanks for clearing that up.
Yeah. All right. Now, yes. So you were talking about a resource, though. You didn't really speak about a resource.
I thought references were resources.
No, I perhaps should have made it more clear. I was thinking of a teaching learning resource. So what it is that I'm asking you to look at, I understand now what you looked at. You looked at resource in terms of these are the resources that the teacher has used. That's fine, but that's not what I was asking you. I'm asking you to look at the resources that she has developed to teach her lesson. And hence a worksheet is one resource that the teacher used. So what I wanted you to do was to look at the resources that she developed for use in her lesson to address the learning outcomes. So I'm sorry if I misled you there, but that was the intention. The intention was to look at a teaching learning resource and how it was used and the quality of it. And I wanted to do that because I made the point earlier that, I may not have made it earlier today, but my point is that as you develop your lesson plan and you develop your resources, I want to see the resources in a form that the students can use. Okay? And so your resource must be, this is what I'm going to give to my students, or this is how I'm going to use it in this way. I don't want you to tell me about it. I want you to create it and to include it. Right? And so that's the reason why I'm asking us to go through this activity. One of the reasons. Okay? For us to be able to evaluate the relevance of the resources that have been developed for these lessons to see whether or not they are in fact useful and relevant. Right? That was the purpose. Okay? So Linton, here we go now.
Okay, looking at lesson 3, I guess questioning was one of the resources that she used. And looking at the question, it begins from A all the way to M. So she had a lot of questions.
Yes, Linton. She has a lot of questions. So you're looking at the sequence of questions in her lesson. But,
right.
But that's not a resource. That's her lesson plan. She's showing her use of questioning as a strategy. Within the context of the questions, she has some resources that she's using. And what I wanted was for you to look at one of them. Okay?
Okay.
Vanessa, I'm having a little problem reading and listening at the same time to what it is that you're contributing. I'm not so sure. But let me just, I'm pausing because I'm assuming that something is wrong with your voice, why it is that you're not speaking. So I'm going to ask us to just look at what Vanessa has said and see if we can comment on it. I'm just reading it. So I'm pausing to read. Okay, there's no need to list the chalkboard. That's a given. Okay. Yeah. No, I realized that you had a problem with your throat, Vanessa. I deduced. I didn't realize, but I figured it must be that you had a problem talking. So you're all seeing the comments. I'm saying with respect to her second question, one doesn't need to list things like your chalkboard and those sorts of things. That those are taken. Those are understood. All right. You just list the materials that you have brought in, that that's outside of the environment, so to speak. Okay. All right. I want to wrap this up quickly. So let's see now. That's Jason and Ava. Let's go.
I give my discussion already.
You gave your discussion already. You gave it already. All right.
My point. Yes, I just probably forgot. Yes.
I want you. All right. Fine. I want you to as well look back at lesson 3 and look at the test. No, I don't mean to do it now. I mean, find some time and look at the summative assessment at the end. She has some questions there on her lesson 3, and look at the questions. Look at how the questions are phrased. Look at the way they relate to the lessons. In other words, I want you to spend some time and look again at these 3 lessons, even outside of this session, and see if you can sort of appreciate, the relationship between the objectives, the activities, the resources, and the questions, because they're all related. All right, and these were really good plans. A difficult topic, really, one in which sometimes one would tend to take on a very passive approach. But I think if you look at the lessons and if you think about how they'll be implemented, you could see that there is an attempt to involve the learner and, of course, to ensure that there is active participation in the actual teaching learning exercise. All right. I'm gonna stop, pause, and bring this thing to a close. It has been a very long period, I know, over the summer with 4 courses, and I had said this earlier to you that I thought that perhaps in going forward, we really do need to consider 3 courses in the summer instead of 4. We're in summer 2. By the time you get to summer 2, you're very tired, and I think summer 1 could do with 2 courses, but I think summer 2 we may have to make it 1 course, and to include the 4th course in the first semester, which may be a little challenging for persons who are teaching and also going back to school. But when I see you face to face, I'll get some more feedback from you. I'll have the full complement of everyone there. So we'll talk a bit about it and get a sense of what your feelings are about that sort of arrangement, so you can begin to think about it. And I also want to say that I understood what you were saying to me, Jason, was that you were not able to, MITS is down, or Orville platform is going to be down because of some upgrade that they're doing. So my recommendation, my expectation is that you would email it to me. All right, so
Yes.
send it by email. All right, because you won't be able to go on the system to do that. I have started looking at your assignment 1, and I'm pretty sure that by tomorrow, when you look on the system, you should be able to see some feedback on it. I should be finished marking, and you'll be able to see the grades that you would have got for that assignment. So that will give you some time to think about how much you have to do and what were your weaknesses with respect to that first assignment. So look for it for tomorrow afternoon. I should be finished by then. I had hoped to have finished today, but yesterday was just a very bad day for me. Couldn't do much marking yesterday. All right. So let me just say.
Well, first, are you referring to the presentations?
No, I'm referring to the piece on inquiry.
Oh, right. Okay.
You forgot that. You've done so much. You forgot that.
I did. Yeah, but the presentations, were you able to find the video?
Oh, sorry. Let's say that the challenge that we're having, we have found the video. It's not that it's not lost. It's because Metz recorded it from home. So it wasn't recorded on the campus because remember it was a public holiday, so she couldn't do the class in the regular way. And that's the reason why that recording has not been posted. But we're working on it, and hopefully it will be done before the end of today so that you can see it. All right, that's the real reason why you haven't seen it as yet. It was done in a different way, and I don't understand the technicality of it, but it clearly has to go through some process to be uploaded, which I don't understand. All right, so that's the reason for that. So we're working on that for you, and we'll hopefully get it through to you before the end of the day, so you can have a chance to see it and interact with it. All right. Are there any questions that you want to ask me at this time?
Yeah. Did you said is the lesson plan supposed to be sent by email? That's what you said. Or over be down? Is that?
Yes, that's what I said.
Oh, okay.
Send it to my email. Okay.
Oh, okay.
And I'm correct. Everything's due on. The table is due on Monday, and
Correct.
part 2 is due on Thursday, correct?
That's right.
Thank you.
Dr. Rainford?
Yes.
I saw on our OR really an assignment is due for Friday.
Yes. You mean tomorrow, Friday?
Yes.
I think that's the one that we have asked you to submit on Monday. We gave some additional time.
Okay.
We said that on Monday's class.
Okay, thank you.
Does everyone have your email address? Because I don't.
Okay, it's marcia.rainford@uemona.edu.jm. So that's marcia.rainford@uemona.edu.jm or marciarainford@gmail.com. So it's my you can send it to my Gmail. Oh, sorry, no, marciarainford@gmail.com. Sorry, that's just my Gmail. So it's Marcia Rainford. So it's marcia.rainford for the UEMONA one, or Marcia Rainford for Gmail. No dot in the Gmail. But Jason has it. So Jason, can you send it to them for me, please?
Send them your email?
Yeah, send them the email.
Okay.
Any other questions? All right. Well, I'm looking forward to meeting you all, and I think you'll be all right. I know that some of you are a little anxious, but don't be anxious. We'll try to work it out so that you don't get too anxious and you don't lose any sleep over this. Tracy?
Dr. Rainford, sorry. I emailed you, I sent you a message to ask you to, where can we find the lesson plan that you showed. I don't think it's an overview as yet, with the different stages. You showed one in Monday's class.
Okay.
If you posted.
The 5E lesson plan?
Yes, you had an example of one because
Yes, man. Let me tell you which one? Which one? Tell me about it.
there's one that I don't think you said you posted it as there. There's one where you have the different phases and each it had the explanations and stuff.
Okay,
I know it's
fine.
like in the
Yes.
charts, but
Oh,
just
yeah,
because
you're
it's
right.
that one.
You're
Yeah.
right. Okay, that's fine. I know which one it is. I'll put it up. Yes, you did send me an email. All right, I'll do that. Any other questions? Okay, Tracy, I have about 5 minutes, and we can spend some time talking about Tracy has some questions about her lesson plan, and she says she doesn't mind talking out loud and sharing. So if she doesn't mind, then we can do this now. Everybody may benefit. All right.
Okay. Well, I'm having problems with the introduction.
Yes.
Because it asks for a discrepant event or demonstration game or video clip.
Yes.
Now, I really wanted to do in a discrepant event, but for the level that I'm at right now, I couldn't find it. It just seems like they're all physics and chemistry for discrepant events.
Yeah.
So that kind of like took that one off the plan for me.
Yes.
So then I said, oh, games are good. So I went and trying to get students is quite difficult. I'm going a long way to get to the answer. I actually had someone helping me with the concept maps for our other class. Yes. And after getting 3/4 of the way through, they said they quit. I have to find someone else. He says, my teacher doesn't make me do concept maps like this. I'm like, okay. I didn't even know. He's only 9. He didn't even know he knew how to do concept maps. So anyway, I have to start that again. So he's not a good option for using as a student. So anyway, in the long run, it's very difficult if you don't have an audience. So what I would like to do is in order to teach the same child, because he's on break apparently, so he told me 1,000 times, I actually took him for a walk, and I didn't let him know that I was teaching him. I was teaching him the characteristics of living things.
Yes.
So when I would walk because he loves walking with me and my dog. So when he would sweat, I was like, wow, it's hot. And I slowly brought all of the characteristics up. Yes. Because I could tell that he hadn't figured out that plants were living. Yes. He knew they were living, but all the characteristics that he told me had nothing to do with plants.
Okay.
Living. If you took a class out and did that same type of walk that I did with him, is that a demonstration?
No, that would be like a field trip.
Even if you're demonstrating, or you're sweating, or your muscles are moving, and
no, a demonstration would have to be something that you do. So you would have to create the situation and show it. Okay, so it's either teacher-led or student-led. But that in and of itself would be an experience that you get outside. So it's like a field activity that you have done. And from the field activity, you have these experiences that you're addressing.
Okay, so then instead of can you obviously I'm thinking strictly about this assignment at this point in time.
Yes.
If I was to do a demonstration and I was just to show different things, but I can't get any feedback from non-existent students, how do you go about sorting out that lack of
interaction?
Yeah. I mean, to me, that's just boring. Like, my character when I teach is I'm going to be very interactive with my students, and I like to joke around.
Yes, your problem is that you can't find any students at this time to really do anything like that with. All right. How do you get around that? Ooh, I don't know. I don't have any ideas in my head yet. Anybody has any ideas? I'm totally out.
Not videotape it. We could just not do that part. That's the solution.
Oh,
Right?
Can you tell that when I like
That's gonna take the fun out of it. That's
all the stress
It's going to solve our problem.
that's gonna take the fun out of it.
and the stress.
Dr. Rainford?
Well, I'm planning on getting my mom or my dad to be my student.
You're trying to get your mother or father?
Yeah.
Yeah, and that's fine. That'd be great. Any such luck, Tracy? Can you find an audience? Any audience, you know?
Everything to. I mean, I can. I mean, I have to do it. I mean, I got an audience for our group the last time we had to do an experiment, but I spent so much time on getting students that I think it was more exhausting than the whole course. And I'll find students. It's just that it has to be relevant. I don't know, it just has to be relevant. Teaching adults about some scientific concept for 11 to 15-year-olds just seems like it's not relevant.
Depends on how much they know. Depends on how much the adults know.
I know smart people.
Oh,
Yeah,
well.
like Vanessa said, you could teach each other.
Yes, I'm seeing what Vanessa is saying, that you could perhaps teach each other.
Dr. Rainford?
Yes, Samuel.
Does the introduction have to be in a classroom setting?
Well, no, not necessarily. It could be in your kitchen.
Thank you.
Yeah, it doesn't have to be a class. The point that Vanessa has raised, we can teach each other. Yeah, you could. You know, it's just, I don't know how you would do that technologically wise, but I mean, I suspect if you can figure a way out, then by all means, you are all in Bermuda together. So there are 4 of you there. You could perhaps find a way to get together and do this if there is a challenge. So that's one way you can solve that problem. All right? That problem can be solved among the 4 of you. Right? If you're having a challenge, Tracy.
No, I was just thinking of options, which is why I was asking you what I did.
Yeah,
So,
yeah.
Right for now, we just, everything that we do has to be time must be considered.
It's time bound, yes, and yeah, that's a challenge with this and because the nature of the activities, these courses are very hands-on courses. It does require that we do this. Next time we do this program, this course is going to be done in the first semester. You won't do this in the summer. It's just too much to do in the summer. So for what it's worth, we have come to that conclusion. All right. I hope that has helped, Tracy. I think that you can in fact do it like that. Get together with some people and
Given that you realize that it has been very heavy load for us in this summer session, does that mean that there's going to be a handicap given to our grades once you've analyzed them?
I don't know what that really means, but what that means, what I have already done is I have adjusted the assignment. I did say that the last time.
Yes. So what I mean by a handicap is,
Yes.
say for instance, we all get 45% on the final grades, 45%.
Mm-hmm.
Does that mean you'll adjust the grading slope to, or 45% or lower? 45% was the best score in the class, so
Yeah.
everybody got 45% or lower.
Yes.
Does that mean that you'll adjust the marking scheme to reflect 45% being like an A? You know what I mean?
Yes, you're asking me about norm referencing as opposed to criterion referencing. And my answer to that question is that this course is criterion referenced. There are some standards that we need to meet. And I don't mark on the curve. I don't expect any of you to get 45%. The assignment is doable. It may take a little while, and I'm prepared to give you a little extra time if you need it, but it's not a difficult assignment. It's by far, it's a lot of stuff that you have to do, but it's not difficult stuff. It's just a lot. So you have to write a lesson plan. You have to do an introduction. You have to look at a resource Those are not really, really hard. It's just that it takes a little time to think it through and to get it done. So if time is the issue, we can give you some more time. You with me?
Thanks.
Yeah. If time is an issue, I can be flexible with time. But you're not going to get 45%, and you're not going to fail, because I don't think that you are not able to do this, right? And so I wouldn't even go there. I wouldn't go there. But if you do fail, then what we normally do is we give you a chance to do over the component that you have failed. If I can get that in before the grades are due, then I'll do that. Yes. Okay.
Can I ask an off?
Yes, Tracy.
An off topic. When will you be in Bermuda?
I think the 1st of September.
So you'll come to the schools that we're at, or will we leave the schools that we're at?
I believe we are to meet for a workshop on, I think it's the 1st or the 2nd, or the 1st and the 2nd. I can't remember now the schedule for you. And I understand that you're coming into me for one day. I think is the 31st a Monday or a Sunday? It's the Monday, whatever that is. I think it's the 31st, or is this, I don't remember. Anyway, it's that last week of August into September. And it's the Monday that we're meeting with you. And yes, you're coming to the campus. Ought to be. All right? We will have a workshop. Any other questions? All right.
I guess the workshop will discuss everything that we need to do for our practicum and stuff like that.
That's right. That's when we're going to be dealing with that. Yeah.
Okay then. All right.
We'll have some time to deal with that then. The workshop really is about the practicum courses for the next semester. All right. Okay then. There are no other questions. I'll see you soon. And I'll see your assignment soon. And I'll give you some feedback by tomorrow on your assignments. All right?
Okay, then have a good day.
Take care. Yes, you too.
Thank you so much.
Yes.
Thank you.
Take care. All the best.
Thank you.
Yeah, all the very best. Take care.
Bye-bye.
Bye-bye.